Welcome back. In this video, I will be showcasing, or not really showcasing, talking about how my floating point arithmetic system works. I'm going to be taking a different approach than what I usually do, where I show functions and what's not, and instead we'll be talking about theory on how it works. If you want to see how it works and understand it, go ahead and look at the Github repo. I do have comments on all the functions. It's probably not as understandable as I could sit down and try to explain it, but I've already recorded a video explaining all the functions, and it was very, very long, and I also messed up near the end, and I didn't feel like re-recording it or editing out mistakes and stuff like that. So I'm just going to be talking about the theory. Before we get started, let's talk about the formatting and stuff. We have in our input thing, we have ArrayMathIn, we have var2 and var1 with our standard number formatting, and then in our main storage space we have a temp value, we have then v1, which is a number, v2, which is a number, and then out. And we're going to go ahead and look at this file here, and this down here is going to be the output of our thing, and these are our inputs. So let's go ahead and start with addition. Now, formatting a number, let's say 24 plus 1.5, that would be 2, 4, and 1, 5, and then our decimal point on this would be 1. Now, adding these two numbers together, you could just add the first slot in each array, which would be 4 and 5. Whenever you add those, my temp value, my hold value, and my base, let's get those set up. Value 1 is 4, value 2 is 5, which then gives me 9 on my temp value. I'm going through what happens on each operation in slow motion, by the way. This will all make more sense here in a few minutes as I get into fleshing out each one of these more. Afterwards, I take the temp value and put it onto the hold value, and then I compare if the hold value is less than the base, then I don't do anything. And I also set that to 0. So my hold value is 9, and then I take my hold value and I append it, or prepend it onto my array here, and also I remove that last number. So my first number here is 9, and then next we are taking 2 and 1, removing these, which then gives us 3 in our temp value, shift it over there. It's less than our base, so we just prepend it, giving us 39, which is not the right answer, you may have noticed. So for addition, I actually have to do something, or there's a separate operation I have to do whenever I initialize an operation. So I start out with 2, 4, and 1, 5. Let's go ahead and reset all these. And what I actually do is, since I have a decimal point of 1 on this one, I have to add an extra 0 to this here. Basically, if I am to take these two numbers and add them conventionally, it is 24.0 plus 1.5. Essentially, adding the 0 here shifts over this number here. So instead of this, it is this. So then what I can do is I can do all that again. So I take the first number here, which is 2 and 5. I add both to my temp value, shift that over there, and so on, and that will give me 255, and then my decimal value will be whatever the greatest decimal value of these two is. For this one, it is 1, so the decimal value will always be shifted over 1. Now, let's say I add something like 24.5 to 1.5. If I actually do those math operations, what's going to end up happening is I'm going to have 5 and 5. So let's put those into my register here. Then in my temp value, I add 5, and then 5 again. So I have 5, and then I add 5 to that, so it's 10. Now if I shift this over to my hold value, my hold and base are greater than or equal to, my hold value is greater than or equal to my base value. So what I do is I remove the base value from the hold value, and then since that, or what I do first actually, is I take and carry the 1 over to my temp value. So my temp value becomes 1, and then my hold value I remove 10 off of because that's my base value, and then I get 0. So what I do then is I append or prepend my 0 onto the list, and then next I am adding 4 and 1. So 4 and 1. Since my temp value has 1 on it, I add the first value, which gives me 5, and then I add 1 again, which gives me 6. I shift that over to my hold value, which then becomes 6. My temp value, or my hold value, is less than my base value, so it's temp, or that. And then I shift this over, so I prepend 6 onto my list. And then the last operation I do is value 1 would be 2. And then value 2 is null because there's nothing left in this array. Since what I'm doing is I'm removing all these numbers. This, once it hits the end, becomes an array with the value end within it. So that's a null value basically. My temp value, then I add 2 to, which then shifts over to my hold value, and since it's less than that, I prepend it, giving me 26.0 with a decimal point of 1 shifted over. Now, this essentially means my result is 26.0, but the thing is, since I have a 0.0 at the end here, I can actually remove that 0 and reduce the decimal by 1, giving me just 26 with a decimal point of 0. Okay, so that's basically addition. Let's move on to subtraction. Let's say I am subtracting 24 minus 36. Now, this will give me the wrong number. I'll get into why here in a sec, but I'm going to show what happens if I just subtract 24 minus 36 if 24 is in position 1 and 36 is in position 2. So let's start out by moving our numbers into our scoreboard, and we'll do that. Now we add 4 to our temp value, and then we subtract 6, which gives us negative 2. We shift that to our hold value, and since our hold value is below -1, so less than 0, I add the base value, which gives me 8, and then I make temp. I turn temp into a negative, into a -1. Essentially carrying the -1. If you were doing 36 minus 24, basically you would do 6 minus 4, which you'd have to carry the 1, meaning you do 6 minus 14, and then you would do 1 minus 3, which you then have to carry, and it just wouldn't work. But what would that output then? You would prepend 8 to the list. Then the next thing you do is 2 and 3. Removing those two numbers, and since I have carried the -1, I add 2 to the temp value, which gives me 1, and then I subtract 3, which gives me -2. I shift that to my hold value, which is -2, and then I add 10 again, which gives me 8. Then I carry the -1, and then I prepend 8 to this list. And now the issue is I have a -1 in my temp value, with 88 as my solution, because I've run out of numbers in my my operation here. Now that just doesn't work. How I get around doing this is I first compare my two numbers, and if value 1 is less than value 2, I invert them. But I invert them internally. The actual input is the same. So basically I am then subtracting 36 minus 24. Now the same or the same thing of carrying over the 1 is still there. So let's actually do 26 minus 34, just so you can see that carrying over and taking place. But what I do is if -1, or if value 2 is greater than value 1, I mark the polarity of the output as -1. So that's how I keep track of the output, because basically if you subtract 2 minus 4, you get -2, which is the same if you do 4 minus 2, which just gives you 2. The logic behind that is the same as in this document here. Basically, if value 1 is positive and greater than value 2, then I do value 1 minus value 2, which is subtraction with a positive result. If value 1 is greater than value 2 and value 2 is negative, I add with a positive result, because subtracting a negative number gives you plus. But if value 1 is less than value 2, I subtract with a negative result instead of subtracting with a positive result. It's basically inverted here. That's the logic basically behind the subtraction. So what I do here is I take 4 and 6, I add 4 to my temp value, and then subtract 6, leaving me with -2. I shift that over to my hold value, then I add the base, leaving me with 8, and then carry the -1 into the temp value, and then I append or prepend 8 onto my output list. And then what I do is I remove those two numbers, leaving me with 3 and 2. So 3 and 2. I carry the -1 from this. So this I add 3 to, leaving me with 2, and then I add 2, leaving me with 4. Or subtract 2, leaving me with 0. I carry that over, and since it is greater than or equal to 0, I do not add the base to it, and then I do not prepend or anything. Actually, I do prepend a 0, but I have some post-processing afterwards that if the first number in the array or the first set of numbers, it basically recursively removes 0 at the start of the output array until it gets to an actual number. And then our result of 24 minus 36 is going to be -8. Or I think I did 26 minus 34 actually. 26 minus 34, which is -8. So that's how subtraction works at its core. Now moving forward on to multiplication, let's do 32 times 24. Now multiplication is recursive adding, and I could just add 32 to itself 24 times, or I could just reduce it down to 6 addition operations, greatly improving the efficiency of the operations, as well as just overall making it it just performs better. So let's talk about how that works. So what I do is I create an extra or new value in the scoreboard called mult, and basically what I do is I have this array from the output, which I put into here. So I start with 0 plus 32. Because I am multiplying 1 times 2. So what I do is I take this first number here and I shift it into the mult value. And then what I do is I take 32 and I add it to the previous number, which is output here. Once I do that, in this case I would get 3, 2. And then the next thing I would do is clear this, and then I would have 32. And then once I add these again together, the first time I do that, I remove 1 off of the mult value. So my current state would be 32 in the output and 32 into the next input. And then I would add these together again, giving me 64, and then leaving my mult at 2. So then I have 64 plus 32, and I keep doing this until my mult would be 0, leaving me with 128 in my output, as you can see. Then the next thing I do is, since I have now run out of numbers in the ones place of the multiplicand, I would then transfer this over and then multiply this by 10. So then I am adding 320 to 128. So let me actually get my calculator out so I don't miscalculate this. 320 plus 128, which leaves me at 448. 448, and then I want to take 448 and add it to 320 again, which then leaves my final output as 768. So 7,68. So that's how multiplication works. Instead of adding a number to itself, the amount of times for the input, I just do it what the total, so 2 plus 4, so I only have to do 6 addition operations in total. So the last operation I'm going to talk about is division. Now, I'm not great at explaining division, but I will try my best to make it understandable. Basically, division in the system is through recursive subtraction. That's what it does. Let me just explain sort of how exactly I do it. So to start out, I take my two numbers here. As you can see, we have 45 and 4. You'll see what this second set of numbers is here for in a second, but this number specifically, why it's here. But basically what I do is I compare the first number and the second number, and I want to make it so the second number is greater than the first number. And once the second number is greater than the first number, or if it's not, I multiply it by 10. And I keep doing that until it's greater. Now that 4 is greater than 45 by multiplying it by 10 twice, I then divide it again by 10. Now I added, the reason I know that I can do that is because I added 2 zeros to this, and I'm keeping track of the amount of zeros I'm adding to each number. I added 2 zeros, so I know I can remove at least 1 to make it back less than 45. So now I do subtraction until it no longer can subtract. So I can subtract 40 from 45 once. If I subtract it again, I will return a negative number, and that's not what I want. So every time I subtract it, I add 1 to the div score. So now I have 5 and 40. So I can no longer subtract 40 from 5. I know that because they are less. This number is less than this number. So what I do then is I generate a number to add to this. So the difference between these two right now is -1. So I take the current decimal point and set it to -1. And what I do is I take this div and add it to the number there, or to the generated number. And then what I do is I take this negative decimal point. I haven't talked about this before, but the system can kind of handle scientific notation. If you mark a decimal point as negative, it means there are that many zeros after the number. So 1 with a decimal point of -1 is 10. So basically what I do is I add 10 to this output number. This is the actual output, leaving me with 10 at a decimal point of 0. So next, what I do is immediately, I have the remainder from last time, which is 5, and then I make this greater, and immediately it's already greater, so then I subtract that again. So now I have 5 and 4. I can subtract 4 from 5 once, leaving me with a remainder of 1, and my div is 1. Now, since these both are the same decimal point, I add 1 to the current decimal point value by default. If there's no difference, I add 1 to it. So now my decimal point is 0 and my number is 1 again. So then I add 1 to 10, which gives me 11 on my current output. So now I have 4 divided by 1. Now immediately 4 is greater than 1. So I cannot remove a 0 from 4. So I have to add a 0 to the next one, meaning I have 1 decimal point extra here. So what I can do is I can subtract 4 from 10 twice, leaving me with a remainder of 2 up here. And now I take this, since this has 1 more here, I add 1 to the decimal point. So my next generated output is going to be a decimal point of 1 and 2. So what I do is I shift over this to add an extra decimal point, and then I add 2 to it. So now I have 11.2 as my output. Now I have 2 divided by 4. Again, since 4 is greater, or the second value is greater than the first value, I add or multiply it by 10, and now I can subtract 4 from 20 5 times, and that is going to be an even number. And since there's a 1 decimal point difference here, I know I have to add 1 more to the decimal point, meaning my next generated output is a decimal point of 2 with a number of 5. And then I add those, meaning my decimal point here is 2, and then I have 5, giving my output of 45 divided by 4 as 11.25, which is what it is. So hopefully that's a coherent explanation of how the division works, as well as the rest of the entire system. Hopefully it all made sense. I've sort of recorded several different ideas of how to explain this, and I think this is the most coherent. But yeah, thanks for watching, and I will catch y'all next time.